Good afternoon, class. We are looking at pre-calculus practice test number 3, module 3, covering chapters 5, 6, and 7. Here's section 6.3, inverse trigonometric functions, and chapter 7, trigonometric equations and identities, also known as analytic trigonometry. What I want to quickly add is the following. When you take the exam, this is what you see. Before starting the exam, please read the following. The following pledge aloud. I pledge on my honor that I will neither give nor receive unauthorized assistance, so on and so forth. In short, when you take the exam, it's absolutely closed everything, okay? Closed notes, closed book, closed PowerPoint, everything. You may use a scientific calculator, and from time to time, maybe a graphing calculator. Just wanted to remind you of that. Now, let's start with the inverse trigonometric functions. We're going to find the exact value of the expression and justify no calculator, tan inverse of tan of negative 2 pi over 3. So, what's going on with inverse trigonometric functions? Because all trigonometric functions are periodic and therefore fail to be one-to-one, because they fail the horizontal tangent line, we have to restrict their domain to make them one-to-one, and therefore they have an inverse. So, for example, for sine inverse, which means y equals sine inverse of x, it results in x being sine y. X is between -1 and 1. This is the range of a sine function. Now, the domain of a sine is all real numbers. The restriction is that we restrict the domain of sine from negative pi over 2 to pi over 2, which becomes the range of sine inverse. And the reason we do that, so it has an inverse. We know f of f inverse of x is equal to x. But again, we have to pay attention to the restriction. If we are dealing with sine inverse of sine, x becomes x if x is between negative pi over 2 and pi over 2. If you're looking at sine of sine inverse of x, then this x belongs to sine inverse, must be between -1 and 1. Otherwise, it doesn't work that. Tangent basically follows sine, and the restriction that we put for sine, we put the same restriction with the difference that it doesn't have the equality, and it works similar to that. Cosine, if we said y equals cosine inverse of x, by definition, x becomes cosine y. And again, just like sine, we put x between -1 and 1 because that's the range of cosine. Remember, the range of cosine is between -1 and 1. Now, the restriction happens that in order to work on cosine, the x is between 0 and pi for cosine x, which becomes the y for cosine inverse. So if x is between 0 and pi, cosine inverse of cosine x becomes x. If x is between -1 and 1, cosine of cosine inverse of x becomes x. Cosecant is 1 over sine. So cosecant inverse, we basically use the same restriction with a slight difference as far as the sine is concerned. So y equals cosecant inverse x, means x equals cosecant y. Secant inverse, remember, secant is 1 over cosine, so it follows the cosine and the restriction that we put on cosine, in which case y equals secant inverse of x means x is secant y. Cotangent, although it's the inverse, the reciprocal of tangent, but that's not how it works. It follows cosine as well. So y is between 0 and pi for that case. And when we say y equals cotangent inverse x, That means x is cotangent y. That's how the restriction works. And now we are ready to tackle this question, everybody. All right, so we are interested in finding tan inverse of tan of negative 2 pi over 3. Negative 2 pi over 3, negative 2 pi over 3 negative 120 degrees puts us in the third quadrant. Remember, the reference arc is pi over 3, and tan of negative 2 pi over 3 is the same as tan of pi over 3. And it becomes square root of 3. So tan inverse of square root of 3 gives us pi over 3. That's how you come up with the answer. So that's the concept of inverse function. We look at more examples. Secant inverse of square root of 2. We have no idea what it's equal to, let's say. So we set it equal to some variable, for example, alpha, beta, gamma. By definition, means secant of alpha must be square root of 2 by definition of inverse function. Secant is 1 over cosine. If secant is the square root of 2, cosine is 1 over square root of 2, or square root of 2 over 2, which makes alpha pi over 4. In other words, from secant, we end up with cosine because we know trigonometric functions of cosine. That's why. Cosine inverse of 1/2. Same thing, we don't know what's equal to. We set it equal to some variable, for example, theta. By definition, it becomes cosine theta equals 1/2. It's a common arc. Cosine theta equals 1/2. Theta must be pi over 3. Again, you should be very comfortable with all common arcs, everybody. Tan of cosine inverse of square root of 3 over 2. So this represents an arc or angle. So something like alpha, beta, gamma, you choose, doesn't matter what. So let cosine inverse of square root of 3 over 2 be beta. Then by definition of an inverse function, cosine of beta must be square root of 3 over 2. Again, this is a common arc. Beta must be pi over 6. So if beta is pi over 6, we are interested in tan of pi over 6, which is square root of 3 over 3. Okay? So it's pretty straightforward, everybody. Cosine of cosine inverse of 1.2. It's undefined. Why is that? Because 1.2 is larger than 1. This number must be between negative 1 and 1. Negative 1 and 1. Think about this. You set this equal. One way to easily see that, if you set this equal to some variable, let's say alpha. That means cosine alpha is 1.2, which has no solutions. So that's important to understand a bit. We're going to move on. We want to find the exact value of cosine of sine inverse of negative 1/3. And I'm going to do it two different ways. I'm going to use a unit circle / triangle, and I'm going to use identities. So ultimately, you really should know both method and figure out which one is easier for you. Let something such as theta represent this expression. So that means you want cosine of theta. That's the meaning of it. We need to figure out what's going on. To figure out what's going on, there are two ways to approach it. One is to continue with this. Of course, sine theta is equal to negative 1/3. Sine is negative. And we are looking at sine inverse. Recall the sine inverse, the restriction is between negative pi over 2 and pi over 2. In other words, the fourth and the first quadrant. And because it's negative, then we are dealing with the fourth quadrant. I'm going to recap this. I want to make sure we understand what's happening. We let this represent theta. By definition of an inverse function, sine theta becomes negative 1/3. If sine is negative, it's either in the third or fourth quadrant. Because the fact we are dealing with sine inverse, remember the restriction is from minus pi over 2 to pi over 2, it puts us in the fourth quadrant. The reason we need that, because we need to know that cosine in the fourth quadrant is positive or negative, and of course, remember cosine is the same as x in the fourth quadrant. X is positive, so is cosine. So sine is negative 1/3. One way to look at it as far as the unit circle or triangle is y over r. And if it's y over r, remember r must always be positive, okay? So y must be negative 1. So what is cosine? Cosine is x over r. X is 2 square root of 2. How do we arrive at it? Let me remind you. So here's this unit circle, x squared plus y squared equals 1 unit circle. In this case, x squared plus y squared is 9 because r is 3, everybody. Normally we use the unit circle. In this case, it's not a unit circle. R is something other than 1. So theta, okay, so we are in the fourth quadrant, and we know R is 3, and P has coordinates x comma y. What is the coordinate for x? We don't know, but for y, we know it to be negative 1. So this triangle, this is 1, this is 3, and this becomes 2 square root of 2 because a squared plus b squared equals c squared. If you work this out, x squared becomes 8, x becomes 2 square root of 2. And so cosine theta is x over r, which makes it 2 square root of 2 over r. So you could use the circle, not necessarily in this case unit circle, but you can use a circle and a triangle. The second method is to use identities. Sine is given. find cosine. You know, sine squared plus cosine squared is 1. That means sine squared is 1 minus cosine squared is 1 minus sine squared, and so on. And cosine is plus minus the square root of 1 minus sine squared. I hope you can see from here you can make up quite a few equations. One of them is this. You have to write plus minus and then make a decision based on the quadrant. Because it's in quadrant 4 and cosine is positive, you use the positive one. And you replace the sign with negative 1/3. This is 1 over 9. You get 8 over 9. And the square root of 8 over 9. The bottom comes out as 3. Square root of 8 is 2, square root of 2. And that's exactly the same answer. Now, the reason I went two different ways, because if they don't ask you what method, you can use any of them. And sometimes one is easier than the other. So as long as you're exposed to both of them, you figure out what is the best course of action. Write a trigonometric expression sine of tan inverse of u as an algebraic expression. Tan inverse of u is, you let it be something, alpha, beta, gamma, theta. When you do that, by definition of tan inverse, tan of theta becomes u. So you have this one as theta. So what are you looking for? Sine of theta. So I hope you recognize this as sine of theta. Well, cotangent theta is 1 over u. Sine theta is a question mark. The reason is because we know the Pythagorean identities, and 1 plus cotangent squared is cosecant squared. Cosecant is 1 over sine. That's why writing cotangent theta is 1 over. Of course, the relationship between tangent and cotangent, they are reciprocals. So 1 plus cotangent squared is cosecant squared. So 1 is there. Cotangent is 1 over u. It's 1 over u squared equals cosecant squared, which is missing. If we take a common denominator, the common denominator is u squared. This becomes u squared plus 1 over u squared. And if I write the reciprocal of this, I have to write the reciprocal of that. What is the reciprocal of cosecant? So let me just remind you. So cosecant theta is 1 over sine. That means sine is 1 over cosecant. So I can write the reciprocal of that and reciprocal of that. Reciprocal of that is u squared over 1 plus u squared. Reciprocal of that is sine squared. So what is sine? The square root of the right side plus minus. We have to figure out positive or negative. And of course, this comes out as u. This remains. And it is positive. The reason why, because sine and tangent have the same sign. Why do they have the same sign? Because both of them take place between negative power 2 and power 2. The difference is, in the case of sine, we also have the equality sign. We are going to move on. Now, in this case, if you use a triangle, it makes it easier because tangent is u over 1. You can go with the right triangle and say opposite over the adjacent. If you draw a right triangle, the opposite is u, the adjacent is 1, and the hypotenuse is missing. So a squared plus b squared is c squared. So 1 squared plus x squared is the hypotenuse squared. So what is the hypotenuse? Is the square root of 1 plus u squared. So sine theta is the opposite over the hypotenuse, and the opposite is u, the hypotenuse we found it to be square root of 1 plus u squared. And I hope you see that they are identical. The difference is this was faster. That's why we learn different methods, and sometimes, as I mentioned, one method works best. Okay, so you have to be comfortable with various methodologies to make sure that you have no problem with this. Okay. We're going to move on, and we're going to move on to sum and difference formulas, double angle, half angle formulas, and so forth. So these are the formulas that we need to memorize, and the proof is in the lecture. Sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. Sine of alpha minus beta is sine alpha cosine beta minus cosine alpha sine beta. The way it works, basically, after we prove this, just replace the b with minus beta and you get that. Cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. Cosine of alpha minus beta is the same thing with the negative sign in between. First, we prove this, and then we replace this one with minus b, and b, it gives this one. For tangent, remember, tangent is sine over cosine. You basically divide the sine of alpha plus beta by cosine of alpha plus beta. You get tan of alpha plus beta. And you do the same thing for tan of alpha minus beta. So sine of alpha minus beta over cosine of alpha minus beta. And you work it out. You end up with what you see. Then we have the double angle. The way the double angles work is very simple. Over here, if I change this to alpha, becomes sine of 2 alpha. So this becomes sine alpha, cosine alpha, sine alpha, and that becomes 2 sine alpha, cosine alpha. So the proof is very simple. Same thing here. If I want cosine of 2 alpha, I'm going to change this to alpha. I get cosine of alpha plus alpha. Cosine alpha minus sine alpha, sine alpha. So it's cosine squared minus sine squared. Now, we know that sine squared plus cosine squared is 1. So we can replace either this one or that one. Cosine squared is 1 minus sine squared. Sine squared is 1 minus cosine squared. If we change them, we can get 2 cosine squared minus 1, or 1 minus 2 sine squared. So cosine of 2 alpha has 3 different formats. And of course, what is tan of 2 alpha? Same thing here. If I change this to alpha, I get tan of 2 alpha. This becomes tan of alpha plus tan of alpha. 1 minus tan of alpha becomes 2 tan alpha over 1 minus tan squared. So after we prove this one, which takes a little bit of time, and this one, the rest are extremely simple. Now, we want to go to the half angle, and that's, again, very simple. Take a look at this formula, for example, the blue one. If I move this to the other side, I get 2 sine squared. This one becomes 1 minus cosine 2 alpha divided by 2. And I hope you see that this blue formula can easily give you that. And then what they do, they change the alpha to alpha over 2. So if I change this to alpha over 2, this becomes alpha. So change. In other words, change it to any variable you want. Okay. If you change this to beta, this must be 2 beta. Okay. Now, for the green one, if you move the -1 to the other side, becomes +1 divided by 2 becomes cosine squared alpha. So green one gives you that. And you do the same thing if you let 2 alpha be, for example, beta, this becomes beta divided by 2. So you can divide by 2. So that's the half angle formula. So if this is sine squared, this is cosine squared, tan squared is the relationship between these two, the ratio of this blue one over the green one. Divide this one by this one, you get tan squared of alpha. So I hope you realize we get this one in the numerator, this one in the denominator, the 2 cancels out. And if you change this to alpha, then you change this to alpha over 2. So the rest of them are very easy to prove. And if you want sine of alpha over 2, for example, you take a root of this one, plus minus. Same thing here, gives rise to this formula. Now, for tangent, you can use this formula. Can also show, and you can find it in your notes, sine alpha over 1 plus cosine alpha over 1 minus cosine alpha over sine. We have the product to sum and sum to product formulas. For now, we are going to skip it, and then I will look at it quickly at the end. For now, use the half angle formulas to give exact value. Sometimes they don't tell you what formulas. You have to figure out on your own. So 195 is half of 390 degrees. And the reason I want you to use that because 390 degrees is a common arc. Please understand why you're using this. This is 360 plus 30, which makes it 30 in essence. That one, okay? So the thing I'm trying to say is that this is a common arc, okay? That's why. And now we are going to use the formula for sine of alpha over 2 plus minus a square root of 1 minus cosine alpha divided by 2. So plus minus a square root of 1 minus cosine of alpha is 390. Now, you have to figure out whether you need positive or negative. Well, 195 or 390 divided by 2, it's in the third quadrant, where sine, you should know, is negative. In fact, sine and cosine are both of them in the third quadrant, negative. So you keep the sign according to the location, negative. And of course, I changed the 390 to 30 because cosine of 30, we should know is square root of 3 over 2. Now, if I multiply the top and the bottom by 2, first of all, these 2, they become 4, comes out as 2. Secondly, when you multiply this one by this one, you get 2. When you multiply this one by this one, you get minus square root of 3. And that's the exact answer. No calculators. Okay. Cosine of 15, obviously. Cosine of 30 over 2. And you use the cosine formula plus minus the square root of 1 plus cosine of alpha divided by 2, meaning 30 degrees. And of course, the reason we want to drop the plus, 15 is half of 30, it's in the first quadrant, right? So you use the plus sign. And cosine of 30, we already did in the previous example. It's a common one, and it's square root of 3 over 2. Again, you multiply by 2 over 2, and you get exactly the same thing as this one with a plus in between. So you get square root of 2 plus square root of 2 plus square root of 3 over 2. That's what you get. Try finding it in the following manner. Cosine of 15 degrees is cosine of 45 degrees minus 30 degrees. You can do that methodology. So there are various formats. Prove the identity. Secant 2 theta is secant squared theta over 2 minus secant squared theta. And to do so, plus we use various identities that we are supposed to know. And when you want to prove identities, you normally start with the more complicated side. There are two sides here. Clearly, the right side is more complicated. So we start with the right-hand side, RHS, right-hand side, everybody. Well, anytime you have various trigonometric functions, one easy way to prove things, go to sine and cosine most of the time. Secant is 1 over cosine, so secant squared is 1 over cosine squared. So 1 over cosine squared, 2 minus 1 over cosine squared. This is a complex fraction. You multiply by LCD, which is cosine squared. When we multiply these two, of course, we get 1. When we multiply these two, we get 2 cosine squared minus these two cancel each other minus 1. Now, 2 cosine squared theta minus 1, you should recognize it as cosine 2 theta. Okay, cosine of 2 alpha, there are 3 different ways, and you should be very comfortable with that. This is the one that will do the job. 1 over cosine 2 theta means secant 2 theta. Again, pretty straightforward, everybody. Part B, sine cubed plus cosine cubed over sine plus cosine is 1 minus sine theta cosine theta. So again, you start from one side, which is more complicated, which is in this case LHS, the left-hand side, everybody. So we start with the left-hand side. So to do this, we keep the denominator intact. What happens to the numerator? You recognize this as a cubed plus b cubed. Reminding you that a cubed plus b cubed is a plus b times a squared minus ab plus b squared. So therefore, sine theta plus cosine theta, sine squared minus sine cosine plus cosine squared. So that's the numerator. Don't touch the denominator. So using this, we will factor the numerator as such. So these two cancel each other. And we move this closer to sine squared because we want everybody to see this. The sum of sine squared and cosine squared is 1. And that's the right-hand side. So we proved it. Sometimes you go from left to right, sometimes from right to left, sometimes from each side you move and you get to a common value. Either way is fine. Solve sine of 3 theta equals 1/2, where theta is between 0 and 2 pi. Well, let's write sine x instead of 3 theta equals 1/2. And between 0 and 2 pi, x has two answers, pi over 6 and 5 pi over 6, where x is, of course, 3 theta. One thing I want to make a point of here. Sine x equals 1/2. Pi over 6 is the reference arc. You should know that sine is positive. Sine, remember, sine is the same as y. Is positive in the first and second quadrant. So in the first quadrant is itself. In the second quadrant, pi minus pi over 6. So what do we do next? Well, x is 3 theta. 3 theta is pi over 6. And to get to the answer, you have to add 2n pi first and then divide by 3. The methodology for multiple angles, to get all of them, you must add 2n pi first. And then solve for theta. To solve for theta, we're going to divide everything by 3, right? So we get theta equals pi over 18 plus 2n pi over 3. Also, 3 theta equals 5 pi over 6. We add 2n pi. And then again divide by 3. And we get 5 pi over 18 plus 2n pi over 3. By the way, everybody knows if you have a fraction divided by a whole number, just multiply these two, becomes the new denominator, right? And you look at this number, you start from 0 and you go all the way to this number minus 1, 0, 1, 2. The reason you go that far and no more, because if you go to the next one, you're going to repeat the numbers. We'll see in a moment what I mean by that. So you plug in 0 here, you get pi over 18. If you plug in 1, just so you see, if I plug in 1, this becomes 2 pi over 3. Since I want the denominator to be 18, 18 divided by 3, 6 times 2, 12 pi. With pi over 18 is 13 pi over 18. If I put 2, I get 25 pi over 18. Okay. We do the same thing for the second. If I put 0, I get 5 pi over 18. If I put 1, this becomes again 2 pi over 3, as I mentioned. or 12 pi over 18. And I need to add this to this one. I get 17 pi over 18 and the rest of it. Now, again, the reason we don't continue, if I did and I went to the next one, number 3. Number 3 here cancels out this. I'm adding 2 pi, which means I go beyond the 2 pi. I really, in essence, I get to the same thing, pi over 18, okay? The same thing here. That's why you look at this number and you use every integer, every whole number, I should say, smaller than that, 0, 1, 2. If this was 5, you would use 0, 1, 2, 3, 4, and you don't use 5. We want to solve this equation, cosine squared minus sine squared plus sine x equal to 0. And to do so, it's important to understand you have cosine squared as well as sine squared. This will tell you what to do. You are going either to change this one or this one. Because this is sine x, you're going to keep this and you're going to change the cosine squared. So what is cosine squared? 1 minus sine squared. Okay, let's say this was cosine. We would keep this and change the sine squared to 1 minus cosine squared. So 1 minus 2 sine squared plus sine x. We put them in descending order. And since this one is the leading term, we're going to make it positive. In other words, take everything to the other side. This becomes positive. This becomes negative. This becomes negative. Okay. It's an easy factoring. And if you have to, you can even say, okay, this is y. So you're looking at 2y squared minus y minus 1 equal to 0. And the factoring of that is easy. 2y plus 1 y minus 1, or 2 sine x plus 1 sine x minus 1 equals 0. So the bottom line is you do the factoring, okay? So either 2 sine x plus 1 is 0 or sine x minus 1 is 0. And if the first one is 0, sine x becomes negative 1/2. If the second one is 0, becomes positive 1. Now, positive 1 just, x is pi over 2. But as far as negative is concerned, remember, first think of the 1/2, which gives you pi over 6. Okay, I want to write it here. Sine x equals 1/2. X is pi over 6. This is the reference arc, okay? Negative, where is sine negative? The sine is negative in the third and fourth quadrants. In the third quadrant, you add pi, becomes 7 pi over 6. In the fourth quadrant, you subtract it from 2 pi, becomes 11 pi over 6. So you have those. And as I mentioned, for sine x equals 1, the answer is easy. We are going to move on to the next question, everybody. Prove the identities. And you start with the more complicated side, which is the left-hand side, and we are going to write the identities that we know, sine of alpha plus beta, alpha minus beta, and so forth. And because this is cosine of power 2 plus x, we're going to use cosine of alpha plus beta. This is the one that we are going to use. Cosine alpha, cosine beta, cosine of power 2 cosine x, minus sine alpha, sine beta, sine power 2 sine x. What is cosine of power 2? 0. What is sine of power 2? 1. Replace them. This goes to 0, negative sine x, and that's the proof. Tan theta over secant theta equals sine theta. We want to prove that, and we're going to start from one side to get to the other one. The more complicated side is the left-hand side. We write tangent as sine over cosine and secant as 1 over cosine. Both of them have the denominator cosine. You can get rid of them or just simply multiply by cosine, and it will do the job. So cosine theta, cosine theta. This is theta, everybody. You get sine theta over 1 or simply sine theta. So it's pretty straightforward. Proof cosine to the power of 4 theta minus sine to the power of 4 theta is cosine of 2 theta. Again, we start from one side. In this case, the left-hand side is more complicated. And we use a squared minus b squared is a plus ba minus b. And this is cosine squared to the second power. This is sine squared to the second power. So we have cosine squared plus sine squared times cosine squared minus sine squared. Cosine squared and sine squared, they add up to 1. So they have no bearing. So it's the second parenthesis cosine squared minus sine squared. Cosine squared minus sine squared is cosine of double angle. In this case, cosine of 2 theta. And that's the proof. What about tan x over 1 plus tan squared x equals sine x cosine x? We start from one side, and again, the left-hand side seems to be more complicated, tan x over 1 plus tan squared x. The denominator 1 plus tan squared is secant squared. So we replace the denominator. Tan x is sine over cosine. Secant is 1 over cosine, so the denominator is 1 over cosine squared. There are two denominators, one is cosine squared. Cosine squared is the LCD. We multiply the top and the bottom by LCD, namely cosine squared. When we multiply these two, we simply get sine x times cosine x. These two cancel each other. So sine x, cosine x is the final answer, which is the right-hand side. So we proved that works. Find the exact value of the expression and justify with no calculator 2 sine of power 8 cosine of power 8, and we should know sine of double angle. Sine of 2 alpha is 2 sine alpha cosine alpha. So following that, we should recognize this as from right to left. Sine of 2 times alpha, 2 times power 8. Obviously, 2 times power 8 is power 4, and sine of power 4 is square root of 2 over 2. So that should be very straightforward. Same thing here. We follow the double angle formula, and this becomes sine of 2 times 45 degrees. And 2 times 45 is 90. Sine of 90 is 1. Cosine of 7 pi over 12. Obviously, 7 pi is 3 pi plus 4 pi, so we can say 3 pi over 12 plus 4 pi over 12, and use cosine of alpha plus beta, which is cosine alpha cosine beta minus sine alpha sine beta. Notice 3 pi over 12 is pi over 4, 4 pi over 12 is pi over 3, so you're adding pi over 4 and pi over 3. So cosine alpha cosine beta, that means cosine of pi over 4 cosine of pi over 3 minus sine alpha sine beta minus sine pi over 4 sine pi over 3, and those are common arcs. So cosine of pi over 4 square root of 2 over 2. Cosine of pi over 3 1/2 minus sine of pi over 2 again square root of 2 over 2, but sine of pi over 3 is square root of 3 over 2. And so I hope you recognize the denominator is 4. The denominator is 4, so simply a fraction bar with the denominator 4. The product of these two is square root of 2, and these two is square root of 6, negative in between. Square root of 2 minus square root of 6 over 4 is the final answer, everybody. Cosine of power 2, cosine of 5 power 2 plus sine of power 2, sine of 5 power 2. And I hope you recognize this one as cosine of alpha minus beta. So cosine of pi over 2 minus pi. Let me just, so you recognize this one, okay? Cosine of pi over 2, pi over 12 minus 5 pi over 12. And that makes it cosine of negative 4 pi over 12, which makes it cosine of negative pi over 3. Cosine is an even function. So cosine of negative pi over 3 and positive pi over 3 are the same. And the answer is 1/2. Cosine of 105, if we can make up two arcs or angles that are common arcs, will save the time. That would be cosine of 60 plus 45, both of which are common arcs. And so obviously, we're going to use this one, cosine of alpha plus beta is cosine alpha, cosine beta minus sine alpha, sine beta. So cosine 60, cosine 45 minus sine 60, sine 45. And each one, we know the value. Cosine of 60 is 1/2. 45 is square root of 2 over 2 minus sine of 60 is square root of 3 over 2. Sine of 45 is the same as cosine of 45 is square root of 2 over 2. And both of them have the denominator 2 times 2 over 4. This is square root of 2. This is square root of 6 with the negative in between. So the final answer is square root of 2 minus square root of 6 over 4.